we're going to go over inequalities. Page 30 in your ISN should be a review of one-step, two-step, and multi-step inequalities. And then we're going to talk about compound inequalities and special solutions. So open up to page 30, and I'm going to get you started on that. You may remember that solving an inequality is exactly the same as solving equations. You use the same steps and use the inverse operations. There is one thing we're going to talk about that we need to remember. But an inequality is just, instead of saying equal, it could be less than or equal to. So there's more than one answer for these equations. It could be greater than, or it could be greater than or equal to. But we're going to use the same methods that we did to solve equations. So when I have a one-step equation, and I have x plus 9, to get rid of it, I want to isolate the variable x. I'm going to minus 9 from both sides. That meant that x, the answer is x is less than 6. Okay, I'm going to remind you how to graph these. We're looking at the number 6, and what we're going to find is it's not equal to, so we put an open dot at 6. When it's less, I'm going to shade to the left. So when I'm shaded to the left, I'm saying that anything smaller than 6 will work for this equation. So if I was to pick a number like 0, 0 plus 9 is less than 15. That's this direction. All these numbers make this statement, x plus 9 less than 15, true. You are looking for the point that you can find on the number line that will make your statement true. There's one thing I want you to remember, though. When we are multiplying and dividing by negative numbers, we have to flip the sign. So when you're multiplying by a negative or dividing, you need to flip the inequality. So on that first question, when it had negative 8 times x, we're going to divide because we want to know what 1x is. So x at 5, that's when it's equal. Negative 5 times negative 8 equals 40. So where is it going to be true that negative 8 times x is greater than 40? Well, if you remembered to flip the inequality, it's when x is less than 5. So there's an open dot at negative 5 because that made negative 8x equal negative 40, positive 40, at negative 5. Okay, but anything less than that should make negative 8x greater than 40, should make that statement true. So pick a number that's less than negative 5, like negative 6. Negative 8 times negative 6 means two negatives make a positive, so now you have 48, and that is greater than 40. So if you're not sure, you can always plug the number into the original equation to make sure that you've graphed and your equation, your answer, is right. Or remember, when you're multiplying and dividing by a negative, flip the inequality. I'm going to let you try the rest of these on your own, but you're following the same steps. You're distributing. You have to move the x terms to the left-hand side and move the constants to the right. So the terms with the variables, and then check your answer to make sure that you have your inequality sign so the x's make the statement true. Try these ones on your own, and we're going to talk about compound inequalities. This is page 30 in your ISN, and there's two types of compound inequalities, and or. So on the and, example 1 and 2, it gives you two things that you're looking for in the inequality. Translate this verbal phrase on the inequality and then graph it. So all real numbers, we have to remember real numbers are rational and irrational. They're any number I can find on the number line. So it says any real numbers that are greater than negative 1. So if I'm greater than negative 1, I must go in that direction. And less than 2. Well, if I'm less than 2, I must go in this direction. So the numbers that are true for this compound inequality are going to be between negative 1 and 2. All right, here's going to be the inequality, how I'm going to write it. I am going to write x had to be greater than or equal to negative 1 So I'm doing a closed dot at -1, and I'm shading to the right. And x had to be less than 2. That means I have an open dot at 2, and I'm shading to the left. So any number in between here will work. All right, 0 is greater than -1, but it is less than -2. When you're solving and inequalities, you really have to set up both equations. So I am going to have to solve -5 greater than or equal to y minus 8. And I'm going to have to solve y minus 8 is going to be greater than or equal to -7. So these are just one-step inequalities. I am going to add 8 to both sides. So I have 3 had to be greater than or equal to y. I think it's hard to read when you have the y on the right-hand side, because really what it's saying is y is smaller than 3. 3 is bigger than y. So I am always going to switch them and say this is y is less than or equal to 3. See how the less than is still pointing to the y in both equations? I haven't changed anything. I had to flip my inequality when I flipped where my variable was. But this makes more sense to me. Y is smaller than 3. So I am going to find 3. If I start at -1, 0, 1, 2, 3. At 3, I'm going to have a closed dot, and I'm going to go shade to the less than part. But I have 2 points, right? And so I'm going to solve this one. I'm going to add 8 to both sides. So y also has to be greater than or equal to 1. So I have y is less than 3, and it's greater than or equal to, so it's a closed dot, 1. So for this compound inequality, it sits between 1 and 3. It could be 1 and 3 because I have the closed dots, but it sits between those. So you just have to make sure you have answered both of those equations, and you shade where those are true. That's for an and. Let's look at or.